Welcome to an introduction to climate change science. This project is a lesson plan for 1 or 2 college class meetings that will form part of the course Introduction to Global Studies. It will discuss the nature of climate change, and the science that has produced our understanding of these phenomena. It will discuss what are called impact chains, that is, chains of causation between warming, climate change, and how these affect human society and activity and well-being. We'll look at the impact of climate change on the natural ecosystems, on the availability of food, on water sources, on coastal habitation and coastal wetlands, on the availability of energy. In general, that's what climate change science looks at. But this lesson will focus on the basics of climate science in order to lay the foundation for a broader course unit on climate change and food security. The lesson will end with some conclusions that are derived from the 2014 final report of the Intergovernmental Panel on Climate Change. That is a specialized agency of the United Nations, of which the United States is a member, which produces periodic reports on the scientific understanding of the climate and climate change. I want to acknowledge the influence of Dr. Srinath Krishnan, a professor at Yale in their Climate and Energy Institute, and he gave the initial lecture at the symposium, or workshop rather, on climate change and food security, which was held at Yale University in their Summer Institute in July of 2015. And his presentation was extremely helpful and forms the basis of this lecture, and he kindly made his slides available, to which I have added other slides, and his information led me to many other sources. First of all, let's talk about what is climate. It's not the same as weather. Weather is what you feel every day, whether it's hot or cold or windy or wet or dry. And it changes all the time. It's the daily condition of the atmosphere. And that's made up of moisture and temperature and air pressure and wind. Climate, however, is whether it's averaged over a longer period of time for a particular region. So in a given area, the climate is expected to be, over a 30-day period, it's supposed to fall into a given range of temperature and a given range of precipitation. That's what climate is. So it's a kind of climate is what you know and expect, but weather is what you get. So why does Earth have the climate it does? Well, first of all, it ultimately all comes from the sun, which generates the energy, both light and heat, and other kinds of energy as well, which are radiated toward and impact the Earth. When the heat hits the Earth, it bounces back and radiates outward all over the Earth, affecting the temperature of the surface of the Earth. The light energy is quite visible. The heat energy is not visible and is generated in long-wave radiation. Also affecting climate are what are called orbital parameters, and that phrase simply refers to the angle of the Earth as it goes around the sun, and the angle at which the heat and light radiation of the sun hit the Earth, because it hits the Earth in different ways in different places at different times of the cycle, and these affect climate. A phrase you've heard a lot of is the greenhouse effect. The greenhouse effect refers to the process by which solar radiation of the sun comes into the Earth, it passes through the atmosphere of the Earth, hits the Earth, and some of it is reflected by the Earth and bounces back into the atmosphere. However, some of what bounces back into the atmosphere does get there, but other radiation from the Earth doesn't make it through the atmosphere because there are gases that make form part of the atmosphere which trap the heat inside. Just like a greenhouse in the winter traps the heat inside the greenhouse, the glass panes of the windows in a greenhouse trap the heat inside even in the middle of winter. If it's 10 degrees outside, it will still be warm inside the greenhouse. Well, in the middle of cold space, we are kept warm on Earth by virtue of the fact that these gases trap heat inside the Earth. This is the end of part 1, and I will go to part 2 in the next screencast-o-matic presentation.